Hello, today's topics are getting us ready to prove lines are parallel. But before we can prove lines are parallel, we first need to have some vocabulary. So let's start there. Transversal. A transversal is a line that intersects two lines at two distinct points. So in this case, D is the transversal. Line D here. This is our transversal. Okay, basically a transversal just cuts through these two other lines. In the next box over, the region between lines C and D is the interior of the figure. And I'll just do this. I'll say this is the interior of the figure. Makes sense. Think of it kind of like a sandwich, right? Where C and D are the bread. So the inside of the sandwich, the interior space, and the exterior space is outside. And by the way, if you think about this kind of as a sandwich, this line that's cutting through, this line here, like the toothpick that you hold the sandwich together with, that's the transversal. Okay? All right, so we have some vocab already. So when we have these lines cut by a transversal, we get pairs or different angles that are created by that. So the first types of angles that we want to talk about are alternate interior angles. So alternate interior angles, pair of angles formed by two lines in a transversal. Okay, so we've got our two lines, basically our sandwich with the toothpick. And the angles both lie in the interior space, so inside the sandwich, but on alternate sides of the transversal. So inside the sandwich, opposite sides of the toothpick. So if I were to, I'm going to actually put in some numbers here. 1, 2, 3, 4, and I'll do the same thing here. So now, do you see that angles 1 and 3 in this case are in the interior space? Actually, all the angles that I've drawn in here, 1, 2, 3, and 4, those are all interior. But 1 and 3 are on opposite sides of the transversal, so those are alternate interior. Likewise, 2 and 4 are also on opposite sides of the transversal, still in the interior space. So I've got two pairs. I've got angle 1 and angle 3, and angle 2 and angle 4 are alternate interior. And what I see with these, I'll just draw 2 and 4 here. We're kind of looking for, do you see the Z? You see how it makes a Z, either pink or blue, makes a Z. So when you see that Z, you want to be starting to think about alternate interior. Remember, alternate sides of the transversal and interior space. So inside the sandwich, opposite sides of the toothpick. Okay, now we can talk about alternate exterior. It's the same idea, except that instead of inside the sandwich, it's outside the sandwich. So it's in the exterior space, opposite sides of the toothpick. So I'm going to label these angles that are in the exterior space. And I'm going to draw in, let's use blue. So in this case, angle 1 with angle 3, right? Angle 1 and angle 3, and then angle 2 and angle 4. These are alternate exterior. Now, this one's not so much the Z, although I can still see a piece of the Z in here, but if I include the angles, it's almost like a dancer, or you might see something else. So in previous classes, I've had people say, "Oh, I see a dancer," or like a person with their arms out and their legs kind of out. Other people say it looks like a tree branch. I've heard antlers, right? But what we're looking for is we're looking outside and across. Okay, so that's the difference between alternate interior and exterior. Interior is on the inside, exterior is on the outside. So in the name, you can hear what it is you're looking for. Okay, so let's do some more definitions. Parallel lines are lines that do not intersect, and we indicate their parallel. Right, you know how we have tick marks for congruent? Well, we also have tick marks for parallel. Excuse me. And we use arrowheads. So I could do one arrowhead, or I could do two arrowheads, right? Or I could even do three if I get excited and want to do that. We cannot assume parallel. All right, this is important, just like we cannot assume right angles. We cannot assume parallel. So we have to be told that they're parallel in order to make these tick marks. I'm going to write this in. By the way, that sort of looks like a double L, but it's actually like train tracks kind of thing. That symbol right there is the symbol for parallel. All right, so I guess I kind of went in a funny order here, but we have this other type of angles that we get when we have the two lines cut by a transversal. All right, going back to that sandwich analogy. Sorry, I went in a different order. But we also get what are called corresponding angles. And corresponding angles, let me label these up too, that'll be helpful. In this case, we're actually going to get a number of corresponding angles, but what we have to have is we have to have the angles on the same side of the transversal, and one of the angles is going to be in the interior space and the other is going to be in the exterior space. The rules sound complicated, but once you see them, I think it makes more sense. In this case, angles 1 and angle 2 are corresponding angles. Gosh, that was loud. So I'm going to draw in the corresponding angles. Okay, so notice that these two angles are on the same side of the transversal. They're both on the right side of the transversal. One's in the interior space and the other's in the exterior space. It's almost like if you were thinking about these as triangles, right? If I just kind of like drew in, right? I mean, those aren't actually there, but what I'm trying to get at is to get you thinking about it in terms of corresponding angles, right? We're really good at that with triangles. So if you sort of think about this as a triangle, even though it's not, you can see which ones are the corresponding angles. And we have a number of corresponding angles here. I mean, I know that this angle here corresponds to this angle here, right? Or this angle corresponds to this angle. Do you see where I'm going with this? Right? They have to be on the same side of the transversal, but one's in the interior space and the other's in the exterior space. All right. So I think we're pretty good with our definitions. Now let's do some practice. All right. So in this case, and there's something else I wanted to just go back and say. Do you see a letter here for the corresponding angles? See the F. So when we look for corresponding angles, we see an F. When we look for alternate interior angles, we see a Z or an N. And when we look for the alternate interior angles, I see sort of like a running person or a dancer or antlers or branches. All right. So in this case, angles 1, so I'm going to mark the angle, and angle 2 are what? Well, what letter do you see? I see an F, and so I'm going to say that these are corresponding. Okay, in 3 and 4, so angle 3 goes like that, and angle 4 goes like that. So what shape do you see? Do you see the Z? So these are alternate interior. Five and 6. See, 5. These are the sides of angle 5. These are the sides of angle 6. Oh, that's definitely a Z again. These are alternate interior. So you see what I'm doing is I'm just highlighting the sides of the angles that I'm looking at, and then I can see a shape start to develop. All right, so now when I highlight the sides of these angles, I don't see the Z, I don't see the F, but now I see sort of the dancer or the tree branch, so these are alternate exterior. Okay? All right, so now that we have the vocabulary, we're ready to start to come up with our theorems, or how do we prove lines are actually parallel. So we have 5 ways to do this. We have 5 ways to prove that lines are parallel. That's quite a bit. And they all start the same way. So you have to pick one of your 5 methods, but they're all going to start the same way. If 2 lines are cut by a transversal such that 2, right? Okay, so here's our situation. We have to have 2 lines cut by a transversal. If in that situation we now have 2 alternate interior angles that are congruent, then we must have parallel lines. So I'm just going to take you back, right? In this case, looking at this one here. Let me look at this. If angles 5 and 6 are congruent, then that must mean that this line is parallel to this line. Right? And if you just think about that for a minute, that should hopefully make some sense to you. Because if angle 5 was, let's say, much bigger than angle 6, wouldn't that tip that top line? In which case, it would open it up more, in which case those 2 lines could not be parallel. So the only way they could be parallel is if those 2 angles are congruent. All right, so if we have a pair of alternate interior angles that are congruent, then we have 2 parallel lines. Same for alternate exterior angles. So now we're looking at this one, alternate exterior angles. So in this case, the 2 parallel lines would be this and this, right? Again, you look at the one line that they share, right? That's the transversal that they share. And what we're saying is that off of this transversal, we have to open the same angle. If we open the same angle off of that transversal, we're going to be forming parallel lines. Okay? All right, another way to do this is, you guessed it, with corresponding angles. So I'm going to go back to this here. Now we're talking about corresponding angles. If the 2 corresponding angles are the same, basically what we're doing is we're taking 2 corresponding angles, 2 angles that are congruent, and we glue them together, right, along this transversal. The 2 offshooting lines, these, would then be parallel. Okay, so we can do it by alternate interior angles being congruent, we can do it by alternate exterior angles being congruent, or corresponding angles being congruent. Those are the 3 obvious, or more obvious, ways to do it. But then we have these others, the last 2. So we did these. The last 2 are if the interior angles on the same side of the transversal are supplementary, or if the exterior angles on the same side of the transversal are supplementary. Okay, so I'm going to go back to the front side of the note sheet just for this. So I'm going to look at this here. So the situation is, if the same side, we're looking at interior angles on the same side of the transversal are supplementary. So in that case, that could be like these two here. And I'm not suggesting that these are congruent. That's not what I'm saying. What I'm saying is that these two are sup. If those two angles are supplementary, then the two lines are parallel, right? So same side of the transversal, supplementary. Then we're going to have parallel lines. Likewise, if I said that on the outside, so exterior, same side, if these two were supplementary, then we would have parallel lines. Okay? So these are the 5 ways that we can prove that two lines are parallel. Most of the time we're using either the alternate interior angles, the alternate exterior angles, or the corresponding angles. Most of the time. But don't forget, there is this same side interior subs, same side exterior subs. Those also work. All right. So if two lines, this is how it starts, you have this situation, then the lines are parallel. Okay? And these are your abbreviations. This is what you can use, the shorthands in any proofs. You can use these. All right? Okay, so let's practice. In each case, state the theorem that proves the lines are parallel. Okay, so we're looking at the tick marks now. Based on these tick marks, what I have is I have alternate interior angles. So alternate interior angles congruent implies parallel lines. This case here, I see the F. These are corresponding. Corresponding angles congruent implies parallel lines. And here I have alternate exterior. And if those angles are congruent, that implies parallel lines. Okay, so for each pair of congruent angles, name which lines can be proven parallel and by what reason. All right, so here are my angles. Oh, those are definitely alternate interior. So what's the transversal? What's the part that's cutting through? It looks to me like AD is parallel to BC, and these are alternate interior. Okay, so now for these angles, look, there's the dancer or the branches or antlers, whatever you see. So now the lines that, look for the transversal, look for the one that cuts through. Here's the one that cuts through. EG is the one that cuts through. So what comes off would then be IH and JF. There's no correspondence in terms of like, oh, I've got to write these I have to name these lines with correct correspondence. There isn't correspondence for lines, so don't worry about that. And these are alternate exterior. And then the last ones, let's see, here they are. Here's my F. These are corresponding. So find the transversal. Here's the transversal, KO. So PM is parallel to ON. These are corresponding. Okay? All right, so now you probably guessed what's coming, and you can see it on my screen, but now we're going to work in reverse. So if we've got these angles are congruent, then we can say the lines are parallel. Well, we can also work in reverse, and that is that If the lines are parallel, then we can say, right, we just do the converse. The converse of these are true. So if lines are parallel, so if two parallel lines are cut by a transversal, then each pair of, right, we go backwards. So the alternate interior angles will be congruent. The alternate exterior angles will be congruent. Corresponding angles will be congruent. And we'll have these interior same side of the transversals will be supplementary, and exterior same side of the transversal will be supplementary. So the 5 methods that we used to prove lines were parallel, we can now use the converse. We can just reverse it and say if we have parallel lines, then these 5 situations must also be true. All right, and here are the shortcuts that you can use in a proof. All right. These are a little long, the ones with the same side interior sup and same side exterior sup. All right. So for number 5, we have which pair of angles do you need to prove congruent in order to state that CT is parallel to EL? All right, so these get a little tricky, so we want to make sure that we know what's going on here. Let's say I wanted to prove CT to EL. If I want those, well, what's the transversal? What's the line that cuts both of these? We have 3 transversals. I've got CE cuts them both. I have TE cuts them both, and I have TL cuts them both. Right? But in order to prove them whoa, that's not where I'm putting my pen. In order to prove them congruent, that's my task. So if I used CE and TL, I don't have an option for the congruence, right? Because then I'm setting it up for, I don't have anything on the alternate side of those transversals. There's nothing going on outside of that. And all I could use would be same side interior supplementary, but that wasn't the goal. The goal was to prove which angles are congruent. So it feels to me like the best transversal to use would be, oh gosh, wrong pen, would be TE. And if that's the case, I'm going to choose these two, right? I'm going to say angle CTE would need to be congruent to angle TEL or LET, doesn't matter how you name that. Maybe we should do, well, it doesn't really matter because it depends on what we're doing in a proof, but if I was using triangles, I would use correspondence. So CTE, let me go LET, just to keep ourselves prepared if we were using triangles to prove this. Okay, so now let's flip it around. Let's say instead of proving CT parallel to EL, we wanted CE to TL. So now we're doing these guys parallel. I think I'm going to use the same transversal, right? And in that case, I want these to be parallel. So now I want angle CET congruent to angle LTE. Okay? All right. So I kind of put it all in one spot. Our five options for proving parallel or proving the congruent angles or the sub angles. So this is the key right here, is that this is biconditional, which means it goes in both directions. Okay, so if you start with the parallel lines, you can move right to any one of those 5 choices, or you can start with any of those 5 choices on the right and move left to parallel lines. Okay, depending on what it is you're trying to prove, that's the direction you want to go. So if I was trying to prove parallel lines, I would say, if this was true, then that is true, right? So you don't want to, you make sure you don't want to write it backwards. All right, that's it. You're done. Make sure that your note sheet is filled out. You're going to bring it to me in class tomorrow. You're going to show it to me in class tomorrow in order to get your homework. Okay, see you tomorrow.